Hi guys, welcome back to Bright Matter Labs. In today's video, we'll be making some quantum dots and trying to dope them with boron. Now, uh, just a little clarification. I'm not making stuff up here. Well, for the most part, I will basically be just stealing some research papers, ideas. So, obviously, I say stealing, but in academia, this is what's called as using sources. So let's at least cite them. So investigation of the synthesis of carbon dots from citric acid and urea, evidence of the formation of organic fluorophores, and the study of their impact on catalysis by Ari Gurel et al. The link's in the description. I'm not gonna. So really, all I'm taking from this is like the first page. Yeah, in their experimental section, right? This is the clearest prep that I've been able to find online in the research paper on how to make quantum dots in the microwave, and there's a problem with that, because what the hell? No, seriously. No, I don't count lead and cadmium using ones, because, god damn it, I don't have lead. Well, I have lead, but there's tin in there too. No, but that's beside the point. It's just, it uses other stuff. It's not just lead. If it was just lead, I might have done it. But no. No, what they were making? Carbon dots. So they're organic quantum dots that don't utilize any lead or heavy metals or whatnot. For the most part. You can dope them with heavy metals, obviously. But that's not what we're doing. No. We're making them in the microwave using some urea and citric acid. There's tons of great videos out there on how you can make this, and I'm adding to the pile because I want to. Uh, yeah, so the prep from the paper is 2.4 grams of citric acid, 3.8 grams of urea in a 100 milliliter Erlenmeyer with 10 milliliters of milli-Q water added. No, I'm not using milli-Q water. You're funny. I'm not doing that. That's completely wasteful. Distilled water is the standard here. Now, it wasn't before. Yeah. Anyway, and then they chucked it in a domestic microwave oven, which was irradiated with 765 watts of microwaves for 5 minutes, transferring the initially clear colorless solution to a dark brown solution. That sounds pretty easy. So, where does the boron doping come into all this? Well, basically, I read another paper, which I will quote in the description once again, because goddamn. I didn't bother printing it out because I didn't actually need any numbers from it, because holy hell, it's so unclear. Also, I think I had to pay for it. I'm not paying for a paper. Basically, they add boric acid to it. So, that. And, they do the exact same thing, and it sort of, effectively puts the boron in the structure, except not really, because it's a microwave synthesis. What the hell do you expect, right? Look, we manage, okay? It puts a little bit of it in the structure, but since obviously it's a goddamn jumbled mess of crap in a microwave, it's also going to do some surface chemistry nonsense at the same time. It's like, it's 50-50. It's two different things when really, technically, we only needed to do one. The surface chemistry part isn't really required, but like, cool bonus, bro. Like, cool. So normally, adding urea, which I colored in yellow for a good reason, makes it go more yellowish. Apparently, doping it with boron helps a lot with exactly this tone of blue, which is quite funny to me. Uh, so yeah, we should be at least able to make blue and yellow quantum dots today. Because yes, we'll make normal ones and doped ones. Because obviously you need to, set a standard. Um, Here's a neat thing. I don't have any boric acid. How about we go make some? Okay, so now that we've made some boric acid, which I took the liberty of crystallizing a little bit of it out, we're going to be attempting to first make the regular carbon dots with just urea and citric acid. I will be following the exact procedure from the paper because I don't want to screw this up. They said to use a larger container than necessary, so I will do that too. And also, uh, hopefully, from what I've read, purifying them can be done with like a centrifuge or something. So I might 3D print one that I can hang crank or something. Um, but we'll see if that's necessary. So let's go ahead and do that. Okay, guys. So I got a little impatient. So as soon as it got dissolved, I just chucked it in the microwave, And as you can see, we got this solid powder as a product, but also a lot of black stuff here that I put some water in to dissolve. I also put a little droplet into about a little less than 10 milliliters of water here in this small graduated cylinder, and if we shine a UV light at it, see? So here, the little black specks, they don't really do anything, which is expected. This, on the other hand, our big thing, well, it glows green, doesn't it? That's pretty cool. So this is all quite consistently green. It's really nice. But this over here, this yellow colored solution, you can see, turns sort of a nice, I don't know, like, I don't really have the word to describe it. Bluish green? Cyan? Not too sure. Turns a little bit bluer than green. Yeah, it does react to UV light, which is really nice. So our initial urea citric acid carbon dots, they work beautifully, as we can see. So yeah, look at that. The green here is so visible. It's wow. Here, for the camera, see. Yeah, it's not very visible inside because I'd have to put the camera down like this. But yeah, and I mean, even in the solution, I think it's quite green. Yeah, look at that. Like a solid green here. God damn. That's beautiful. So, I'm gonna take this stuff, I'm gonna centrifuge it, and we'll see if that gives anything. And then after, uh, I'll come back and we will try doing it with some boric acid. So, catch you guys in a second while I centrifuge the stuff. So, as you guys saw from that glow test, the boron doping was completely successful. I mean, we got a nice, beautiful blue glow there. Now, as you saw, the other carbon dots, which were the control, aka urea and citric acid, were greenish. They're supposed to be more of a yellow, but the reason I think they were more green than anything is because while citric acid is supposed to go down a bit towards the blue side, and the urea brings it towards the yellow. We have more urea than we have citric acid, so it's supposed to be yellower. But the thing is, I think some of the urea actually, well, the nitrogen from it actually sort of left the whole mixture, because my microwave was actually a higher wattage than in the research paper, by about 400 watts, roughly. This essentially means that um, some of the nitrogen in there escaped, which gave a higher citric acid to nitrogen ratio, which is probably what caused it to be more green. But the thing is, I didn't want really yellow carbon dots. I really wanted green and blue. So this is a success for me. I'm quite happy with this result. And yeah, I hope you guys liked it too. I'll catch you in the next video. Bye.